Let's take a look at this example. This time we're supposed to design full adder. Okay, so the full adder has 3 inputs and 2 outputs. The difference between full adder and half adder is that full adder has carry in input. So how it works? This is nothing else, just adder, okay, like the name says. We're supposed to add these 3 bits together and check what we're going to have at the output. So let's take a look. We have 0 plus 0 plus 0. So let me write this over here. 0 plus 0 plus 0 is equal binary 0. Okay, so I have 0, 0. That's why I'm going to write over here 0, 0. Next, let's verify this combination. So I have 0 plus 0 plus 1. So I have 0 plus 0 plus 1. 0 plus 1 is equal binary 1. I have 0, 1. That's why I'm going to write over here 0, 1. Next, I have 0 plus 1 plus 0. This is binary 1. 0, 1. I'm going to write over here 0, 1. Next one, I have 0 plus 1 plus 1. 0 plus 1 plus 1 is equal binary 2. 1, 0. So I have 1, 0. Next, I have 1 plus 0 plus 0 is equal binary 1, because 1 plus 0 is equal 1. So I'm going to write 0, 1. This is 0, 1. Next one, I have 1 plus 0 plus 1. Okay, so we have 1 plus 1 is equal binary 2. I'm going to write 1, 0. So this is 1, 0. Next one, I have 1 plus 1 plus 0. This is binary 2. So I have 1, 0. I have 1, 0. I have 1 plus 1 plus 1 is equal binary 3. 1, 1, 1, 1. So we found the truth table. Okay. So now we can simply write the Boolean expression, and after that we can implement the diagram. Okay, so let's write first the Boolean expression for the sum, okay, for this column. So what we are going to have, I'm going to have 1, 2, 3, 4 terms. Okay, so I'm going to have terms C, B, A. I'm not going to write C in just in order to make it simple. So I have CBA plus CBA plus CBA plus CBA. Now we have to look at the highs. I have 1, 2, 3, 4. That's why I have 4 terms. And next, anytime I have 0, I'm going to write the bar over the particular variable, okay, because I'm using SOP. So I have 0, 0, 1. So I have 0, 0, 1. Next one, I have 0, 1, 0. So I have 0, 1, 0. Next one, I have 1, 0, 0. So I have 1, 0, 0. Next one, I have 1, 1, 1. Okay, so this is my Boolean expression for the sum. Next, we're supposed to perform the simplification. Check what we can factorize, okay? So we can say that we can factorize from these 2 terms C0. And from these 2 terms, I can factorize C. That's why I'm going to write that this is C0, and inside of the parentheses, I'm going to have B0 A plus B A not plus C, and inside of the parentheses I'm going to have B naught A naught plus BA. Okay, so continue, we have C naught, and I'm going to convert this expression to the exclusive OR, because this is nothing else, just exclusive OR. So I have B exclusive OR A plus C, and this is nothing else, just exclusive NOR. So I have B exclusive NOR A. Okay, so because they are complements, I'm going to call this for a moment Q, and this one I'm going to call Q naught. So let's take a look what I have obtained. I have C naught Q plus C Q naught. Please notice that this is nothing else, just the exclusive OR. That's why I can rewrite this as C exclusive OR Q. Okay, continue. We said that Q is exclusive OR. That's why I'm going to substitute Q by exclusive OR. So I'm going to have C exclusive OR B exclusive OR A. I can rewrite this as C exclusive OR B and exclusive OR A. So this is the Boolean expression for the sum output. Okay, so next I supposed to look at the carry out column. Okay, so we have how many highs? 1, 2, 3, 4. We have 4 highs. Again, I'm going to write CBA plus CBA plus CBA plus CBA. Again, I'm going to use SOP. So I have 0, 1, 1. So I have 0, 1, 1. Next, I have 1, 0, 1. So I have 1, 0, 1. And I have 1, 1, 0. And I have 1, 1, 1. Next, I'm supposed to perform the simplification. So what we can do? We can factorize from these two terms BA. And from these two terms, we can factorize C. Okay, so let's take a look what we are going to have. If I'm going to factorize BA, and inside of the parentheses I'm going to have C naught plus C. Okay, so my circuit is going to be simplified, or I can say my Boolean expression is going to be simplified because C naught plus C gives me 1. So I have OR, and I'm going to factorize C, and inside of the parentheses I'm going to have B naught A plus BA naught. So C naught or C, this is 1. So I have BA times 1 is BA or C, and this is nothing else, just exclusive OR. B exclusive OR A. Okay, so this is the Boolean expression for, of course I'm supposed to write equals, for carry out. Okay, so this is for carry out. Now I can draw the diagram. So I have three inputs. I have input A, I have input B, and I have input carry in. Okay, don't forget that in our Boolean expressions, okay, C represents carry in. Now we're supposed to implement these two expressions. Please notice that we do not have three input exclusive OR gate. That's why we have to make three input exclusive OR gate using two input exclusive OR gates. So how I'm going to do this? Simply draw something like this. I have exclusive OR gate connected to input A and is also connected to input B, and I have exclusive OR gate connected to the output of the first gate and to the input carry in. Okay, and this is my output, which is called the sum. Next, I'm supposed to implement this expression. Okay, so I have AND gate BA. Okay, so I'm going to use these wires. So I have my AND gate. So now we're supposed to draw another AND gate because I have multiplication over here, and I'm going to draw this gate over here. Okay, this gate, AND gate, this one, is connected to input C. Okay, and is connected to the output of the exclusive OR gate. I mean, because I need at the input B exclusive OR A. So I'm going to make this connection over here. And these two gates supposed to be connected to the OR gate. Okay, so this is my OR gate and this is my carry out. Okay, so I can say that the full adder is designed and problem is solved.